All right, welcome back. Hopefully you just kind of played right on and went into the second video here. There was no assignment from that first one. There will be after this. But I want to look at a sample problem. So we're going to look at a sample problem. I'm not going to look at mean, median, mode, mid-range, and standard deviation range and interquartile ranges yet. We'll do those a little bit later on the calculator. Right now I'd like to focus in on taking raw data and creating a frequency table, and then using the frequency table to create a histogram. All right, so let's look at some sample data. So in this sample data, I'm going to ask students, how many siblings do you have? And here is an example of where we could run into a lot of problems with bias and errors. I mean, what is a sibling? We probably need to better define this if we want to have accurate data. For example, I could ask one person how many siblings, and they have a couple of stepbrothers and stepsisters, so they might include them. Whereas somebody else that I ask how many siblings, and they don't think about their stepbrothers and stepsisters as real siblings, so they don't include them. And maybe I ask somebody else, and they've got an older brother or sister that's away from college or in their 30s and is married, so they don't even think about them as being a sibling anymore, so they wouldn't include them. So we would have to be a lot more careful. How do we define this? What do we include as siblings and what do we not include as siblings when we would ask this question? But let's say that we've very well defined that's not going to be an issue. And we're going to ask, let's make our numbers nice and easy here. We're going to ask 100 students, 100 people, how many siblings do you have? Now, we're going to get a set of raw data. For example, I go up to the first person, how many siblings do you have? They say 2, so I put down a 2. How many siblings do you have? 0. How many siblings do you have? 3. And if I was in class right now, I'd probably go around the room and do this activity and ask each one of you after we define what is a sibling and what's not. And then I would use the data from the room. But since I'm not able to do that, I'm going to give us a set of data here. So the data set that we would get, there would be 100 different numbers. Each of those numbers would represent one of my data points. And this 100 would be a subset of my population. Maybe the population is all students in high school. So I don't want to go around and ask every single 2,000 plus students, how many siblings do you have? So I pick a subset of 100. And let's say we followed all the rules. We're doing a nice, good, well-defined, random, simple sample. And we've got 100 people, and they all responded, so there's no issues there. So let's say all of that stuff was taken care of. Now, when we look at our data, so we've got 100 data points here, just data points, how many siblings. The first thing we want to do is organize the data into a frequency table. Now in the frequency table, we're going to organize the data, and we're going to look at the number of siblings, and the frequency. How many times did that occur? And let's say my data set went from 0, 1, 2, or 3. We're going to keep it nice and simple here. So I looked through all my raw data. How many times did people say they had no siblings at all? No siblings whatsoever. And let's say that 48 of my respondents, 48 of those 100 said no siblings at all. How many said they had one sibling? 32. How many said they had 2? 17. How many said that they had 3? 3. And that should add up to give me 100. 100's nice and easy. I'm trying to make the numbers easy. I'm focusing more on the process than the numbers. So 48%, 48 out of 100 said no siblings, 32% 1, 17% 2, 3% 3. And if this is a good subset of my population, then I could say that 48% of my students, 48% of students have no siblings, because 48% of my sample had no siblings. And remember, if this is a good, reliable sample, then I can generalize these findings to the entire population. Only 3% had 3 siblings. So here we've organized all of our data into a frequency table. The next thing we want to do is we want to create a histogram. Now in the histogram, I'm looking at my classes. I've got 0, 1, 2, and 3. Those are the different classes. By the way, is this data discrete or is it continuous? Did anyone else? Did anyone answer that out loud? That's kind of funny. Did anybody say answer me out loud? That's funny. It's discrete data because 0, 1, 2, 3, not continuous. You can't have 1 2/3 of a sibling. So it's not continuous. It's not from 0 to 3, all of the numbers. It's only 0, 1, 2, 3, discrete type of data. These are going to become my x-axis. Now it's going to be a little strange here because I'm going to have 0, 1, 2, and 3. Now my y-axis is the frequency. So this is my class. In other words, the number of siblings. And this is my frequency. And it looks like the biggest class was 48, so I'm going to make this a 50 here. Let's see, halfway between them would be 25, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And if we were doing this as part of our IA, I think I'd use graph paper or use some sort of software to make a nice printout. If this was a project or something, I would do it a lot nicer. But here we're just doing a sketch. We're just doing a rough sketch here. All right, so now I need to put my bars in there, to put my histogram in there. So, and notice how 0 is not the axis. That's kind of strange to see it that way. Another one of the reasons why this is not just a bar graph. So 48 people. So 48 is right about up here, so I'm going to go up to about 48. And it's a little bit kind of, well, what exactly is that? So to avoid any confusion, I'm just going to put the number 48 up there. That's how big that bar is. How many had 1? 32. 25, 30. So 32 is right about here. And I'm going to put 32. How many had 2? 17. 5, 10, 15, 20. So right about here-ish. 17. And 3 would be down here somewhere. And 3 people had 3. So there's the histogram. Notice that all of the rectangles are connected. There's a space here between the y-axis. This is the frequency, how many times. These are the different classes. If we had another group, let's say that nobody said 3, but a couple of people said 4, then this would have nothing there, and then 4, it would have a line here with 0, and then I would have 4, I would have another rectangle over here. All right, so that is the histogram and frequency from the raw data. We'll talk about the nature of this data. What did we get here? What did we assume? What did we get? How can we generalize this to our population? But I think now you're ready to go on and do exercise set 5C. Look at the hints in the data asking you to do a bunch of things. You're going to have to create frequency tables and draw histograms. All right, I'll talk to you tomorrow.